Okay, so ladies and gentlemen, you are welcome. So in this video, we are going to look at the basic introduction of organic chemistry. And don't forget, my name is Mukhtar Aliyu. So what is organic chemistry? Organic chemistry is actually a branch of chemistry that deals with the study of carbon-containing compound, typically involving carbohydrogen bonded. So, ladies and gentlemen, in organic chemistry is one of the branches of chemistry that trying to study the compound containing carbon. So, it typically involves only carbon containing compound, and some of the compounds that are involved in carbon hydrogen bonds. So, let's look at the examples of this carbon compound. We have carbon dioxide is an example of carbon compound. We have DNA is also another example of carbon containing compound. We have methane. We have ethanol is also an example of carbon containing compound. And we have benzene, which is also another example of carbon containing compound. So these are the compound, or these are the examples of compound that contain carbon. So in organic chemistry, the first thing that we shouldn't forget is one of the branch of chemistry that deals with the study of carbon compounds. So, but it's not all the carbon containing compounds that are considered as organic chemistry. There are some compounds, despite the fact that they have carbon in them, but they are not considered as organic compound. Like, for example, a carbide. Whenever you have a metal reacts with carbon, like for example in the case of calcium carbide. So a metal carbide is one of the examples of compounds that contain carbon, but it is not considered as organic compound. Secondly, we have carbonates. So any compounds that contain carbonates, for example, metallic carbides or metallic carbonates is also considered as examples of compounds that are considered inorganic, despite the fact that they have carbon in them. Like, for example, calcium carbonate here. So the trioxocarbonate, four compounds, they are compounds that contain carbon, but they are not considered as organic compound. Then, so another examples we have cyanide. So metallic cyanide, that is a metal containing cyanide in them. They also contain carbon in them, but they are not considered as organic compound. Like, for example, when we have potassium, Cm, so this is actually metallic cyanide. So it's also another example of compounds that they contain carbon in them, but they are not considered as organic compound. Then another examples, we have other exception, like when we have carbon dioxide and carbon monoxide or pure carbon forms like graphite and diamond, they are also considered as inorganic. So, ladies and gentlemen, these are the examples of compounds that they contain carbon in them, but they are considered as inorganic compounds. So, then the next thing is one of the experiment, or one of the researcher called Frederick Walha in 1928 was able to synthesize urea from ammonium cyanide. Was a pivotal moment for proving that organic compound could be created outside of living systems. So this Frederick Walha is one of the scientists that was able to synthesize organic compound from inorganic compound, meaning that even from outside living organisms, you can synthesize and create organic compound. And that is how he was able to synthesize urea. So this is the picture of the scientist, which is Frederick Walha. And this studies was conducted in the year 1828. And for his experiment, he actually used ammonium cyanide, where he heats the compound and then he generated urea. So, ladies and gentlemen, the main important of this is for you to understand that the organic compound can be synthesized or can be generated from non-living system or outside living system from inorganic compounds. So now, what are the major elements in organic chemistry? So the major element in organic chemistry is carbon. So carbon is a major element, which is the backbone of most organic molecules, forming because of its ability to form chains, the ability to form rings, and also branches. So one of the very important things that is associated with carbon is that it is the versatile compound. It is the backbone of almost all organic compounds because of its ability to form long chain, rings, and branching. Like, for example, this is a carbon where you can see that you can have a carbon singly and bonded to 4 different atoms because of its tetravalent nature. And this is also another carbon. So a carbon can form a chain with itself. And also look at it here, there is a 3 chain where 3 carbon linked themselves together. So this is one of the major reasons carbon is considered as the most important backbone that are found in almost all organic molecules. And in addition, one very interesting thing is that carbon can form a cyclic compound. You see, this is a cyclic compound. So a carbon can form cyclic or a ring compound. So you see, this is a ring compound. So carbon have that ability, and that is why it is considered as the most important backbone of organic molecules. And also importantly, often bonded to carbon. So hydrogen is mostly bonded to carbon, forming hydrocarbon, and in the presence in many other organic molecules. So one very important thing is that hydrogen also bonded with carbon atoms in most cases to form hydrocarbons. And also in addition, another element that found in organic chemistry, which is also one of the very important one, we have oxygen. So oxygen usually forms various functional groups like alcohol and ketones in organic compound, which determine the properties of organic compound. So what is a functional group? So a functional group, it can be an atoms or a group of atoms that determine the properties of organic compounds. So oxygen is one of the very important elements that forms so many functional groups. And examples, we have alkanal, aldehyde, ketones, alkanoic acids. So see, this is a typical examples of where we have oxygen present in organic compound. And here you can see that because of the presence of the oxygen, it forms a special homologous series, which is ethanol. So then, very importantly, nitrogen is also one of the very important elements that are found in organic compounds like proteins and nucleic acid. In addition, apart from the nitrogen, there is sulfur, which also found in amino acid and also other important biomolecules in the body. There is also phosphorus. A phosphorus is also another very crucial element or very important element that can be found in nucleic acids, which is DNA and RNA, and also energy storage molecules. So it can be found in DNA, it can also found in RNA, and also ATP, which is the energy storage molecules that are found in living organisms. So ladies and gentlemen, as we can see here, we have 6 major elements that are found in organic chemistry. So then why carbon is considered, or why carbon is a major element in organic chemistry? So one of the reasons why carbon is considered as a major element in organic chemistry is because of its tetravalency nature. So carbon actually have 4 valence electrons on its outermost shell, and because of those 4 valence electrons, it allows it to form 4 covalent bonds. It allows it to form 4 covalent bonds, and this makes it versatile and able to connect with many different atoms, including itself. So carbon has 4 electrons on its outermost shells, which considered as a valence electrons of carbon. And due to that, it can form 4 covalent bonding. So that is why it forms a very strong covalent bond with so many other elements. So because of that 4 covalent bond, it connects with so many other elements. It connects with sulfur, it connects with nitrogen, it connects with oxygen, it connects with hydrogen, and including itself. So you see, this is where we have carbon. So we can see that the number of protons in carbon is 4, and then the neutron is also 6. So it means that it has 6 atomic number. So you see that in the first shell, this is the nucleus. This is the nucleus. So in the first shell, we have 2 electrons, and then the last one we have 1, 2, 3, 4, and that is why it is 2, 4, meaning that there are 4 valence electrons, indicating that because of this tetravalency, 4 valence electrons, so 4 different hydrogen atoms can connect with carbon, form a single covalent bond, forming a methane. So that is what happened. So because remember, hydrogen have only 1 electron, so it can form a covalent bond with 1 bonding pair here, so another one with bonding pair here. So that is how we have this tetravalent carbon. So it connects with, like for example, carbon can connect with itself, like in this case. It can connect with hydrogen, like in this case, because of its tetravalency nature. Then catenation. One of the very important things, carbon atoms can bond to each other to form a long chain and ring chain, creating a structural diversity essential for complex organic molecules. So catenation is in carbon, it is actually the ability of the carbon to form a long chain. So you see carbon can form a long chain, like here, where we have a long linear chain of carbon, and it can also form branch. So a carbon can actually form a branch compound. So you see this is a branch here. This is also another branch here. Then we have another branch. So it can form a linear, it can form a branch compound. It can also form a ring or cyclic compound, like in the case of this one. This is cyclopropane, this is cyclopentane, and this is cyclohexane. So this is one of the very important reason why carbon is considered as a major element in organic chemistry: tetravalency, catenation. And then the next thing is why also carbon considers a major element is because it has the ability to form single, double, and triple bond. Like for example, look at it. A carbon can form single bond between itself. So you see carbon form a single bond between carbon and hydrogen. It can be between carbon to carbon, like in the case of alkane. And also additionally, a carbon can form a double bond, and it can also form triple bond. So in the case of methane, it is single bond. In the case of alkene, it is double bond, while alkyne, it is triple bond. So this is where you are going to start with the basic understanding of this organic chemistry. So it can form a single bond, it can form, so the carbon can form single bond, can form double bond and triple bond. And this is also another reason why carbon is considered as a major element. So it can form single, double, and triple bonds. And also it is versatile bonding. So carbon readily bonds with other elements like hydrogen. It can also bond with oxygen. It can also bond with nitrogen and halogens. And this enables the creation of a vast array of organic compounds. So you see carbon can bond with hydrogen, carbon can bond with oxygen, carbon can bind with nitrogen, and carbon can bond with itself to form a double bond, and it can also form a triple bond. So because of this, it is nature, that is why a carbon can form a vast array of organic compounds. So these are the 4 major reasons why carbon is considered as a major element in organic chemistry. Number 1, it has the ability to form tetravalent bonding, and it also have the ability to undergo catenation, and it can form single, double, and triple bond. And lastly, the versatile bonding nature of carbon, where it bonds with different atoms, it connects with different atoms. So then the next thing is classification of organic chemistry. So basically, organic chemistry is divided into 2. We have hydrocarbon and non-hydrocarbon. So when we say hydrocarbon, from the word hydro and carbon, it means that it's a compound that contains carbon and hydrogen only in it. So they contain carbon and hydrogen only in them. That is why they are called hydrocarbon. And then in the case of non-hydrocarbon, it means that they are compounds that contain other atoms. They contain other atoms like nitrogen, they contain like sulfur, they contain they contain phosphorus. So in the case of non-hydrocarbon, it means that they have other atoms apart from carbon and hydrogen. So in addition to carbon and hydrogen, they also have other atoms. So that is what happens in the case of non-hydrocarbon. So then now the classification of hydrocarbon. So hydrocarbon can be classified into two. It can be classified into aliphatic or alicyclic, or it can be classified into cyclic. So from the word aliphatic or acyclic, it means that those compounds that are in open or that have open chain, meaning that they are in the form of a linear form. They doesn't form a cycle. It can be branch, it can be linear. So then the aliphatic or acyclic is divided into two, saturated and non-saturated. So from the word saturated, it means that a compound that have carbon to carbon single bond in them. So there is not any double or triple bond in the case of saturated, meaning that they are completely saturated with hydrogen atoms in the case of hydrocarbon. So in the case of saturated hydrocarbon. But for the unsaturated hydrocarbons, they either have double or triple bond in them, and they have deficient of 2 or 4 hydrogen. So in the case of alkenes, they have deficiency of 2 hydrogens, and in the case of alkynes, they have the deficiency of 4 hydrogen atoms. So in the case of alkenes, they have at least 1 double bond in them, while in the case of alkynes, they have at least 1 triple bond. So they are actually recognized by the presence of that triple bond in the case of alkyne. While in the case of alkenes, they are recognized due to the presence of double bond. While for the alkenes, they have only single bond in them. Then for the cyclic, they divide it into two. We have homocyclic and heterocyclic. So when we say homocyclic, it means that they are compound that in their ring, they have the same atom, like carbon, carbon. But in the case of heterocyclic, it means that apart from carbon, there are also other atoms in the ring. It may be nitrogen, it may be sulfur or oxygen. So like, for example, now, let's look at the saturated hydrocarbon. So you see this is butane, this is pentane, this is isobutane. So we can see that in the case of N-butane, N-pentane, and isobutane, you can see that they all have single bond in them. So that is why they are considered as saturated. But for the unsaturated hydrocarbon, you can see that they have at least 1 double bond. Like in the case of propylene, butylene, beta-butylene, you can see that they have double bond. And then in addition, for the acyclic, you see this one, all these ones that you are seeing, this one is a typical example of homocyclic, meaning that in the ring, it's only carbon that is present in them. And that is why they are called homocyclic compound. But in the case of in the case of heterocyclic, you see all this H that you are seeing here is carbon, all this here is carbon, but you'll realize that there is oxygen in the ring. So that is why it is heterocyclic. Here is nitrogen in the ring. That is why it is also considered as heterocyclic. So for the homocyclic is divided into two. We have aromatic, we have non-aromatic, and we have anti-aromatic. So these are the basically 3 classification of homocyclic compound. So ladies and gentlemen, please follow me on this my YouTube channel to watch more videos on organic chemistry. And this is the starting point of the course, and I hope that you will find it very easy. Follow it up and join my YouTube community. Subscribe, follow up, and join my YouTube community. More videos are coming. So we are going to upload the next video. So don't forget to subscribe and join my YouTube community. Bye bye and see you next.